Okay, and now we will first recap what we have discussed in the previous class. Now, in the previous class, we have discussed the construction of op-amp, how op-amp is being constructed. Second one is your mathematical model of the op-amp. Now, whenever we have discussed the mathematical model of the op-amp, the output voltage of the op-amp, that is represented by V0, is equal to gain and the difference between the two input of the op-amp. Two input of the op-amp is represented the voltage inverting and the non-inverting, that is V1 minus V2. Okay, now if the gain in the op-amp is A, so Vd is nothing but V1 minus V2. So V1 minus V2 is the voltage at inverting terminal and the voltage at non-inverting terminal. Okay, so this is the difference between these two voltages. Now after that we have discussed the transfer characteristics. Now in the discussion of the transfer characteristics, we have also mentioned that V0, that means the output voltage of the op-amp, can never exceed the supply voltage. Now if the supply voltage, that means that also implies that the linear region of the op-amp is very small. I am again drawing the characteristics. So this is the characteristics of the linear region of the op-amp. Okay, and this is the saturation region. So whatever may be the gain of the op-amp is A into Vd. Now the output voltage cannot exceed the supply voltage. Suppose the supply voltage is V saturation, this is the saturation voltage. So the supply V saturation and minus V saturation, this is your supply voltages. So your output voltage cannot exceed the V saturation and plus V saturation and minus V saturation, whatever may be your gain. Though the gain of the op-amp is very much high, it is a very good amplifier, but one point you must remember that the linear region within the op-amp must be operated within this linear region. Okay, then only it can amplify it. But beyond the linear region, whatever may be the gain, your output voltage will be fixed at plus Vsat and minus Vsat. So that's why the this is the transfer characteristics of the op-amp, and this is the linear region and this is the saturation region. So this is one of the limitation of using the op-amp, and also the linear region is very small. Okay, so next one is the ideal op-amp. Now whenever we discuss the ideal op-amp, we have said that in the case of the ideal op-amp, it is a voltage amplifier. Op-amp, we have discussed the op-amp is a voltage amplifier. Now in the case of the voltage amplifier, likewise in the op-amp, input resistance is infinite, output resistance is tends to 0, that means almost equal to 0. That is the characteristics of the voltage amplifier. That is also applies to op-amp, as op-amp is a voltage amplifier. Okay, and also input current drawn by the op-amp is 0. That means in the op-amp I have discussed that there is inverting and there is non-inverting terminal, and the current drawn by the both the terminal in the case of the ideal case is 0. And also the ideal op-amp gain is infinite for the ideal op-amp. So this is the ideal op-amp characteristics that we have discussed, and these characteristics you must remember for the easy understanding of the different calculations of the op-amp. So next one, we will discuss the differential amplifier, how op-amp is being amplified the voltages given its input, that we will now discuss. So op-amp is based upon the because previously I have said that the output voltage of the op-amp is the difference between these two voltages. So op-amp must be a amplifier which is a differential amplifier. Likewise in the transistorized differential amplifier, it also amplifies the difference between these two voltages. That concept is also applied in the case of the op-amp, because the mathematical model tells that the output voltage of the op-amp is nothing but the gain into difference between these two voltages, so that the differential amplifier must be used for the construction of the op-amp. So I am just give you a diagram for the saving of your time. 1 minute. Okay. So this is the differential amplifier. Okay, this is the diagram of the differential amplifier. Now you can see in this diagram, this is a voltage, this is a voltage, and this is the two input of the op-amp, inverting and the non-inverting. Now differential amplifier, as I have said, the amplifies the difference between the two voltages. The two voltages is here V in 1 and V in 2. Okay, no input current can always be assumed. That means the current drawn by these two terminal, is 0 ampere. That means no current is being drawn by this two terminal, and this is your inverting input and this is your non-inverting input. We will also discuss the inverting and the non-inverting input in detail, how it is. And the output voltage of the op amp must be between the minus V supply or the V saturation and plus V supply. So plus V supply and the minus V supply must be applied to the differential amplifier, and the output voltage cannot exceed beyond that. So your V plus you may consider as V in 1 and V minus as V in 2. So your output voltage is nothing but differential gain into V plus minus V minus. So nothing but AD into V in 1 minus V in 2. So op amp is nothing but a differential amplifier which amplifies the, and this is called the differential gain. This is your differential gain. Okay, so this is nothing, a differential amplifier, and the op amp is also a differential amplifier which can amplifies the difference between these two voltages. Okay, so next we will discuss the inverting amplifier. Now this is the, as I have said that this is the inverting input. Okay, so this is the inverting input and this is the non-inverting input. So op amp can also be operated by these two configuration, inverting amplifier and the non-inverting amplifier. Now what do you mean by the inverting amplifier we will also discuss, and what do you mean by the non-inverting amplifier then we will also discuss it. So before that, quickly I am just importing the diagram of the inverting amplifier. Okay, so this is the diagram of the inverting amplifier. You can see this is a very easy diagram. Okay, so in the case of the inverting amplifier you can see that I have given only input to the inverting amplifier and nothing has been given to the non-inverting amplifier. That means non-inverting terminal of the input has been grounded to 0 volt. Now as the op amp is current on by the op amp is 0 ampere, so the voltage drop across Rin is also 0 volt. So there is no current drawn, so this voltage across the Rin should be 0, no input current. Okay, so V minus is here equal to V in and V plus equal to 0, because you can see that the V minus is V in and V plus is 0 connected to ground. Okay, so as I have previously said, in the case of the differential amplifier, that is your gain into V plus minus V minus. This is the simple equation. Now V0 equals to AD, V plus is 0 minus V in. Okay, very simple. So it is nothing but minus AD into V in. So this is your equation for V0. Now if 1 minute, I am just removing all this. So if V in is equal to greater than 0, so your output voltage V0 less than 0. Now if V in is less than 0, your output voltage should be greater than 0. Okay, so V0 has a opposite polarity to V in. You can see if V in is greater than 0, V0 is less than 0. If V in is less than 0, V0 will be greater than 0, because there is a negative sign here. So you can say that V0 has 180 degree phase shift to the with the input, 180 degree phase shift. Okay, so in the case of the inverting amplifier you will see this relation. That means V0 will be represented by minus AD into V in. This is the equation for V0, and also V in, if V in is positive, V0 will be negative. If V in is negative, your V0 will be positive. So V0, that's why it is said in terms of phase relationship, V0 has 180 degree phase shift with the input. Hope you understand this, the inverting amplifier concept, and whatever concept I am discussing it, whatever concept till now I have discussed is open loop configuration of this op amp. Okay, so next we will discuss the non-inverting amplifier. In the case of the non-inverting amplifier, as the inverting amplifier is 180 degree phase shift with the input, non-inverting amplifier has 0 degree phase shift with the input. Okay, output of the non-inverting amplifier and the with the input is 0 degree phase shift. So I am just quickly fetch the diagram of the non-inverting amplifier. Okay, so you can see this is the non-inverting amplifier. The same diagram is there. The only difference is that here the inverting input is being grounded to 0. In previously you can see that the non-inverting is being grounded to 0, but in the case of the non-inverting amplifier, inverting is grounded and input is given to the non-inverting input. As I have already said previously, 0 current is being drawn by the op amp in the case of the ideal condition. So 0 volt is being dropped across the Rin. So your V plus will be V in 1 and V minus equal to 0. So your V0 equal to, follow the relationship, AD into V plus minus V minus. So your V minus will be 0. So V0 equal to your gain, differential gain into V in 1. Okay, so no negative sign here, no negative sign is there. There is no negative sign, but in the case of the inverting amplifier there is a negative sign. So yes, 0 degree, that's why it is called the 0 degree phase shift. That means output voltage and if the input voltage is positive, output voltage is also positive. If the input voltage is negative, output voltage is also negative. So V0 has the same phase, V0 has same phase with as V in 1. Okay, so there is no phase difference between these two. So this is all about the non-inverting amplifier. Okay, so next we will discuss the feedback concept. This is, until now we have discussed the open loop configuration. Now what is the feedback concept? All of you know that the op amp is operated with the negative feedback. Now what is the advantages of the negative feedback? Why we give the negative feedback to the op amp? That concept we will discuss next. Okay, so after discussing the non-inverting amplifier, we will now discuss the concept of feedback. Now all of you know, before that whatever concept I have discussed, this amplifier, non-inverting amplifier, this is the inverting amplifier, you can see there is no feedback. Okay, so all of you know that the op amp is being operated with the case of the negative feedback. Now for that purpose we will discuss the concept of feedback. Now you can see this is the input, this is an open loop gain, this is the forward path. Okay, and this is the output. Now this output is being feedback to the, feedback is consists of two terms, feed and back. Okay, so this output, sum of the output, not all of the output, sum of the output is being again feedback to the input, and this concept is, this is a summing amplifier. Okay, so this concept is extensively used in case of the control system. So all of you know the control system, this concept is being used. So feedback, as the feedback is there is input, there is output, and the sum of the portion of the output is being feedback to the input, and this is the summing amplifier, summing or the difference amplifier, whatever you can say. Okay, the summing element. So this is the input, you can consider as being, okay, this is an error signal generated from there, V. This is the forward path, there is open loop gain, and this is the output voltage V0. Okay, and this is the VF, feedback signal, Okay, now as I have said that feedback means two terms, feed and back, sum of the portion of the output. Okay, feed the output signal back to the input, feed the output signal back to the input, that's why the term feedback. Now as I have said, not all of the output, some of the output signal is being feedback to the input, so that's why VF is some portion of the outputs, that portion is represented by beta. So beta is always less than 1. So suppose the output voltage is 10 volt, we want to feedback the 2 volt, so that's why beta is 0.2 into 10, so equal to 2 volt. So that's why beta is always less than 1, because we are importing some portion of the output to the input. So that's why this is called the, so this is called the feedback signal. Okay, so beta VF equal to beta V0. Now forward path, In the case of the forward path, this is, you can see the term is written as forward path. Forward path is nothing but input to output, and feedback path is output to input. So there is a difference between these two. Okay, so why we and also there is a path, the error signal. This is the error signal V. So V can be represented as I have said, this is a summing amplifier or the difference amplifier. So V can also be represented as V in plus minus VF. Okay, so and this is the feedback path. Feedback path is beta. Okay, so V can also be written as V in plus VF. So if this is error signal is V in plus VF, this is called the positive feedback. So if the error signal, I have said that if the error signal is V in plus VF, this is called the positive feedback. And if the error signal is this error signal is nothing but the input plus minus this feedback signal. So if the error signal is V in minus VF, so this is called the negative feedback. Okay, so this is I have again repeating, this is the input signal, this is the output signal, this is the forward path, this is the feedback path, this is the feedback factor, this is the feedback voltage, this is the error voltage. Now the feedback voltage is portion of the output voltage, that's why beta V0 and beta is less than 1. Now V can also be represented as V in plus minus VF. Is V is represented by V in plus VF, it is called the positive feedback. Is V is represented by V minus VF, it is called as negative feedback. So this is all about the definition. Now why we use the negative feedback? So first advantage of using negative feedback, control the gain of the op amp. Control gain of amplifier. Okay, and second one is the control bandwidth. Third one, reduce distortion. Reduce distortion. This is the some of the advantages of the using the negative feedback. Okay, and fourth one is reduce environmental effect. So this is some of the advantage that anyone can get using the negative feedback. Now the control of the gain of the amplifier. What do you mean by that? Op amp is nothing but amplifier. Now as I have said, the gain of the op amp, ideal op amp, is infinite. Now if you can operate the gain of the ideal op amp likewise in this way, then whatever may be your input voltage, if the ideal gain of the op amp is infinite, okay, so whatever may be your input voltage, that means your gain output voltage is your gain your difference voltage. Okay, so whatever may be your input voltage, that means the difference voltage, if the gain is infinite, so output voltage is always be goes to plus Vset or minus Vset, so outside the linear region that we do not want. Okay, so that's the point. We want to control the gain of the operational amplifier. So to control the gain of the operational amplifier, we must reduce the gain so that we can operate the amplifier into the linear region, so not in the saturation region. So to operate the transistor or the operational amplifier in the linear region, we must reduce the gain. To reduce the gain, we must use the negative feedback, because negative feedback actually reduces the error signal. Okay, and also if the gain is reduces, in the case of the frequency response of the amplifier, all of you know that the gain into bandwidth equal to constant. Now if gain is reduces, your bandwidth must be increased. So that's why it is written that the control the bandwidth, that means bandwidth is also increases. Now as we control the gain of the amplifier, our stability is also increases. So as the stability increases, so we must reduce the distortion and we must reduce the environmental effect. So that is the some of the advantages of using the negative feedback. So this is the advantage, some of the advantages of using negative feedback. Now in the negative feedback, how you can implement the negative feedback, and with the implementation of the circuit diagram we will see, and how you see how do you control the gain of the amplifier. I have also said that the first point, that as the gain is infinite, it will always go into the plus Vset and minus Vset output voltage. Now if you can reduce the gain with the help of the negative feedback, then you can control the gain, so that our operation of the amplifier or the op amp can be restricted to linear region. Okay, so that we will discuss the negative feedback. Okay, so negative feedback, you can see resistance is connected with the feedback resistance, it will be connected and means feedback to the negative terminal, that means the inverting terminal. And also this is the inverting amplifier, because we have given input to the inverting input and ground the non-inverting input. Okay, so and also this is the supply voltage plus B and the minus B. Hope the circuit is clear to you. Now the feedback signal should be subtracted from the input signal, so that it is the negative feedback. So your error signal or the feedback signal must be V in minus VF. I have also said that in the case of the negative feedback, input signal should be our feedback signal should be subtracted from the input signal, so that is your error signal. So the error signal your reduces, so V is reduces due to the VF, because there is a VF, so your V reduces. So V0 equal to your V0 output voltage, your output voltage is equal to A into V, error voltage. Okay, so as V is going to reduces, your V0 is be going to reduces. So due to the negative feedback, V0 reduces. Due to the negative feedback, V0 is going to be reduces. Okay, so gain, this is the gain from there, this is the gain. Okay, AF, this gain. So this gain, effect of on this gain, AF is equal to V0 divided by V in. Okay, so your V0 will be A into V divided by V in. Okay, so and also VF equal to your this V equal to A into V in minus VF. Okay, this is V in minus VF. So and beta F equal to VF equal to your VF equal to beta into V0. So your V0 is nothing but your V0 is nothing but A into your V0 into 1 plus A beta equal to A into V in. So you can just simplify this. So I am just going to simplify that. Okay, I am just writing all this again. Your V0 equal to A into V in minus VF, and your VF equal to beta V0, VF equal to beta V0. So V0 equal to, so just get V0 common, 1 plus A beta equal to A V in. So your V0 divided by V in is nothing but A divided by 1 plus A beta. Okay, so you can see from there is beta is equal to 0. If beta equal to 0 in this equation, your open loop gain, it is going to be open loop, as there is beta no feedback path, there is open loop, and this is your gain, this is your gain, V0 by V in your gain will be open loop gain A. Now is beta is not equal to 0, is beta is not equal to 0, gain is going to be less than A, and that we want. Gain is less than A. With the feedback path, gain is going to be reduced. As gain is going to be reduced, your stability will increase. Operational amplifier will going to operate into the linear region, as gain is going to increase, gain into bandwidth equal to constant, so bandwidth will also be increases. Okay, so that is the two term I have discussed previously, the control the gain and control the bandwidth. And if there is a no V saturation and plus V saturation, so there is no distortion. Distortion is also going to be reduces in the case of the negative feedback. So that is the point I want to discuss. Okay, so in the case of this is the inverting amplifier, also this is the inverting amplifier, this is an inverting amplifier. Now in the case of the inverting amplifier, V0 we have also discussed in the case of this open loop configuration, V0 equal to K into Vin, opposite, just the opposite. Okay, so also Vf equal to beta V0. Okay, so Vf is nothing but minus beta K into Vin. Okay, so Vf is opposite to Vin. Your Vf will going to be opposite to Vin. Okay, as Vf is opposite to Vin, so whatever you are going to given to the input, that will be subtracted from the, this is your error voltage, and this error voltage is going to be given to the forward path, and gain is A, so that is going to be amplified A into V. And again same calculation is being applied here, this is the same calculation, this calculation will leads to this. Okay, so this is the advantages of using the non-inverting. That's why this is called the all of the feedback is going to given to the negative terminal, providing the negative feedback. And we will see eventually that if we going to, and this is called the degenerated feedback. Negative feedback is also called the degenerated feedback. Okay, degenerated feedback. And eventually we will see if we use the positive feedback, then it will going to increases the gain again, not it will reduce the gain. So that's why it is unstabilize the output. That means it do not stabilize if the gain is very much high. In the positive feedback, if we use the positive feedback or the inverting non-inverting amplifier, then we will see previously gain is A, and after connecting it to the positive feedback, that means portion of the output is given to the positive portion of the op amp, then we will see gain will again increases from A, it will again increases. So gain will increases, output will be eventually go into the plus beta and minus beta. That is not the operation of the amplifier. If the output is being constant, then what is the being use of an amplifier? It must be operated into the linear region. Okay, so that you must remember. Okay, so I am just importing the diagram. Okay, so this is the non-inverting. So non-inverting is positive, use example of a positive feedback. Okay, so this is the positive feedback. You can see that the output voltage is given feedback to the positive portion, and it is the non-inverting amplifier, because inverting terminal is grounded and input is given to the non-inverting input. Okay, now here the error signal. What is the error signal? Error signal is going to be V in plus Vf. Unlikely in the previous case, it is V in minus Vf. So Vf increases, Vf increases. So Vf actually increases the effective input. The effective input or the error voltage is going to be increases. Okay, it is also called the regenerative feedback. So V0 equal to forward path gain into V. So V is nothing but V in plus Vf. Okay, so Vf equal to beta 0, all of you know that. So if you just put, so V0, Vf equal to beta V0, so V0 1 minus A beta equal to A into V in. So your V0 will be by V in is nothing but A divided by 1 minus A beta. Now if your beta in this case equal to 0, then there is no feedback path, so gain equal to A. Now your beta is not equal to 0. Then you can see in the previous case, in the non-inverting amplifier or the negative feedback, sorry, inverting amplifier or the negative feedback, gain is reduces, but here gain is positive feedback, gain is increases from A, gain is increases from A, is greater than A. That is not desirable. So that is not a application of the amplifier, because the output is eventually goes into the saturation region, plus b sat or minus theta. That is no use of the in the case of amplifier. Amplifier should be in the case of the linear region. That is not here, so it is not used as an amplifier. It can be used as an oscillator. It can be used as an oscillator. Okay, so the positive feedback or the non-inverting input of the op amp can be used as an oscillator. Okay, and also in the previous case that I have discussed, a v0 equal to minus k v in. So here in the case of the non-inverting case, v0 equal to k into v in, there is no phase difference between the input and the output that I have already discussed. So beta f equal to vf equal to beta v0 and vf equal to k beta into v in. So vf and v in are in same phase. vf and v in same phase, not out of 180 degree phase. Okay, so from these two example you can easily see that how we can implement the op amp as a negative feedback. And previously you have well understood that the negative feedback can be used for the different purpose. If you want to operate the operational amplifier into the linear region, and can be used as an amplifier, and want to reduce the gain, want to increase the bandwidth, want to reduce the distortion, want to reduce the environmental effect, then we must use the op amp in the case of the negative feedback. And the negative feedback means output voltage must be feedback to the negative portion of the negative input of the operational amplifier. Negative input means inverting input. Here this diagram output is feedback to the negative portion. Then we can implement this concept as negative feedback in the case of the op amp. But if we just connect the op amp or the negative output voltage feedback to the positive portion, then it is going to be no longer an amplifier, it is going to be an oscillator. And what is the concept of oscillator, what is the disadvantage of the positive feedback, what is the concept of oscillator, we will discuss later. But for the time being, you just know that it is not desirable to connect the operational amplifier, or the output voltage cannot be connected to the positive portion of the that means the non-inverting input cannot be feedback to the non-inverting input, because in this case it is going to be used as an oscillator, no longer an operational amplifier. This amplifier term will vanish, it will no longer be used as an amplifier. Okay, so this is all today. Next day we will discuss the virtual ground concept. Okay, so virtual ground is a very important concept. If you know the virtual ground concept, almost 90% of the problem in context of the operational amplifier you can solve it very easily. So today what we have said, I am just going to summarize. So this is the recap of the previous class. Ideal case, then we discuss the differential amplifier, what is the case, then we discuss the inverting amplifier, obviously open loop case, then we discuss the non-inverting amplifier, obviously the open loop case, then we discuss the concept of feedback, what is the concept of feedback, how the output and the input voltage, and what is the advantage of using the negative feedback. Okay, and then in the case of the feedback, we know what is positive feedback, what is negative feedback. Okay, and this is the linear region, this is most important, and this is the saturation region that we don't use as an amplifier. This is the use of an amplifier. And gain is actually infinite in the case of the ideal op amp. So if you want to reduce the gain to be used as an amplifier, that is the use of a negative feedback. And then how we can implement the negative feedback in the case context of op amp, that we have discussed in the case of the inverting amplifier and the non-inverting amplifier. Okay, you study on your own, then the concept will be clear to you. Any question will be welcome. Thank you.